Yes, sir.
Hi, Alice, can you hear me?
Yes, sir.
So let's start. We want to start from differentiation. Differentiation, which we know very well that if I have a y is equal to x to the power of n, then if I'm differentiating in general, the general formula is n x to the power of n minus 1. That's the basic formula that we apply. Of course, we apply different rules, product rule, change rule, and all that. So differentiation by parts, for example, if I have y is equal to x to the power of 5 minus x to the power of minus 3 plus x squared. Again, differentiate this by parts, dy over dx. That's 5, x to the power of 5 minus 1 is 4, minus multiply by negative what? By negative 3. X to the power of subtract minus 3 minus 1, that's minus 4, plus 2, x to the power of reduce 1 to the power of 1. So that gives you 4x to the power of that negative, that's a positive 3x to the power of minus 4 plus what? That's 2x. You agree? That's simple. If I have something like this, I can also apply integration by, let's say, x cubed plus x squared divided by x to the power of 4. So what I would do if I have this, instead of even using the quotient rule, I can actually divide everything by x to the power of 4 plus x squared divided by x to the power of 4. When I do that, using laws of indices, this becomes x to the power of minus 1. Do you agree? Plus
Yes, sir.
x to the power of minus 2.
Minus 2.
Then when I'm minus x to the power of minus 2 minus 2 x to the power of minus 3. That's basic differentiation. But now, there are times when we are given, okay, whilst we are still on that, if we integrate e to the power, differentiate e to the power of x is there in the formula bullet that I gave you. It remains e to the power of x. But now if I have y is equal to e to the power of ax, if I differentiate that, I differentiate this with respect to x, it's simply a. So it becomes a e to the power of ax in general. Making sense? So for example, if I have y is equal to e to the power of, let's say, to the power of x squared, then dy over dx. What is the differentiation of x squared? Isn't that 2x? So it's 2x e to the power of x squared. That's what we say here. It's the differential of this with respect to x multiplied by this. Is that making sense? Are you there?
Oh, yes, I muted because there was sound in the background.
Oh, okay. That's fine. So let's say now we have something like this. Now, I can't expand this. So the only way I can differentiate this, that's where product rule applies. Because I can't expand this. It's in its simplest terms. And these terms are very different. I use product. So your product rule, according to your booklet that I gave you, it says dy over dx is equal to v du over dx plus u dv over dx. Is that making sense? That's now you don't have to memorize this or even to look at your booklet, because I'll show you what's simply happening is what you do. Tandy, you have joined us. I think so. Chandy, can you? Yes. So what you simply do, what you simply remember with the product rule is, if I differentiate this, I multiply by this term. I don't differentiate. Then plus, I now differentiate this, I multiply by that. That's all we are doing. So if we start differentiating this one here, we get 2e to the power of 2x. Multiply by sine x, we don't differentiate the sine x, plus, now this time now we have to differentiate sine x. Differential of sine x is what? It's there in your booklet. So this one we're not differentiating. What's the differential of sine x? Isn't that cos x? It's there in your booklet. Cos x like this. Then we are done. Or if you want to simply
Is it negative?
yes, you can write 2 sine x plus cos x like that. That making sense?
Yeah. Yes.
So let's look at another example. If I have y is equal to x to the power of minus 4 cos x. We want to differentiate this. Chandy, can you hear us? I think she's online. Maybe her audio is not connected. So if we differentiate, we can choose to differentiate this by order. So dy over dx is equal to, if I differentiate this, what do I get? Minus 4x to the power of what? Minus 4x to the power of
3 minus 3.
no. Remember, it's n, x to the power of n minus 1. So if you say minus 4 minus 1, how can you get 3? So it's negative what? Negative 5. Okay. Drop this x to the power of minus 5. Cos x, we don't differentiate it. Plus, now we have to differentiate cos x. What is cos x? It's there in your bullet. What's the differentiation of cos x?
Minus
yes.
sin x.
So minus sine x, like what you said, multiplied by minus x to the power of negative 4. So now that's minus 4 x to the power of minus 5 cos x. Negative times negative is a positive, plus x to the power of minus 4 sine x. Is that making sense?
Yes, sir.
Product rule. I think Tandy, can you hear us? Maybe audio or something. I think she's connected. Now, chain rule. I'll show you the long way, then I'll show you the short way. So, for example, if I have y is equal to 2x plus 1 to the power of 5. Now, if I want to differentiate this, I can use chain rule. Chain rule, basically, I can write it like this. It's there in your book. Dy over dx is equal to dy over du multiplied by du over dx. That's your chain rule, your general formula. So what I do is, what's in the bracket here, I can say let u be equal to 2x plus what? Are we together? So if we let u be equal to that, it means this term here simply becomes y is equal to u to the power of 5. Because I'm saying let u be equal to this. So it means y is equal to u to the power of 5. Then from this here, we can differentiate with respect to u, du over dx is equal to, if I differentiate this here, it gives me 2. This gives me 0, simply 2. Are we together?
Yes, sir.
Then from this here, dy over du is equal to 5 u to the power of 4. Making sense? We are doing the long way. I'll show you the short way just now. So now if we now apply this formula here, dy over dx is 5u to the power of 4. Multiplied by du over dx, which is 2. That gives me 10u to the power of 4, which is equal to 10. What is u? U we said is this. So 2x plus 1 to the power of 4. Are we together? Now, that's the long way of doing chain rule. So I'm going to show you the short way of doing this. So the short way of doing this, of doing everything and coming up with the answer straight away, which is also allowed in the exam. So what you can do, if you are given this, what's in the bracket is your u. So in your head, you're thinking of y is equal to u to the power of 5. So to differentiate this straight away is you drop the 5 years of 5 brackets, your u to x plus 1. Then you reduce this by the power of 1. It becomes 4. Then what you should, most students end up there, then this answer will be wrong. You always multiply by the differential of what's inside the brackets. The differential of what's inside in the bracket is 2. Therefore, we get 10 bracket 2x plus 1 to the power of 4. Are you there?
Yes, sir.
So, can you try this? Y is equal to 1 over 3x minus 2 to the power of 3. Can you try to differentiate?
Using which way?
Okay, I'm back now. I still there. So to be quick to differentiate this, we have to remember if we say 1 over x in math is good as x to the power of minus 1. Same approach here. So this is y is equal to 3x minus 2 to the power of negative 3. Maybe. So
Yes.
dy over dx. It's using, remember, just think of this as y is equal to u to the power of minus what? Minus 3. Yeah? In your head, this is u here. So that gives you negative 3 u to the power of subtract 1 here, negative what? Negative 4. So that's minus 3 brackets 3x minus 2 subtract here negative 4, but multiply by the differential. Differential of negative 2 is 0. Differential of 3x is 3. The differential of what is 7. So that times that gives you minus 9 brackets 3x minus 2 to the power of negative. Clear?
Yeah.
Now, if I have y is equal to 2 over 4x minus 2 like this, square root. So for this to be easy, we have to rearrange this. So this is the same as writing y is equal to 2 brackets 4x minus 2 to the power of negative
Minus 1.
yeah.
Half.
It's negative half. Square root.
Oh,
That's 1 over square root. So negative half.
all the square root.
Yes. So now, dy over dx is equal to 2 multiplied by this, the power is minus half. Multiplied by what's in the brackets 4x to the power of minus 2. Subtract 1 here, it becomes minus half minus 1, it becomes minus 3 over 2, minus 1 in that. Multiplied by the differential of what's inside the bracket, which is 4. So if you multiply 2 times half gives you minus 1 times 4. The final answer becomes minus 4 brackets 4x minus 2 to the power of minus 3 over
2.
clear?
Mm-hmm. But we used to copy.
Okay.
Okay, I'm done.
Now let's say we have y is equal to 1 over 4 over x squared plus 2 like this. Something like that. Okay. So again, we need to rearrange this. So this is y is equal to 4 brackets 6x squared plus 2 to the power of minus 1 over 4, fourth root. Clear? Because otherwise, if you are not able to do this, then you won't get it correct. That's the first step. Then now, we now try to apply everything in the level. So now,
So the 4 is going to multiply
yes,
minus
correct. That's
1.
correct. So 4 multiplied by the power is minus a quarter. Brackets 6x squared plus 2. Subtract 1 here. If you subtract negative quarter minus, it becomes 1 and a quarter, it becomes minus 5 over 4. But you can use the calculator. minus quarter minus 1. So multiply by the differential of what's inside. This gives you 0. The differential of this is 12x. Clear?
It's 5 over.
So if I multiply this here, I get minus 1. Multiply by 12x, it becomes minus 12x. Bracket 6x squared plus 2 to the power of minus 5 over 4.
Wait.
Your question?
Oh, wait, 4 times. 4 times.
4 times
Minus.
7, that's negative 1.
Negative 1 times 12. Okay. Yeah.
Clear? Now we apply the same, that's what I want to show you now. We apply the same when it comes to trigonometry. So I'll start with an example, an easy example. So e.g., if I have y is equal to sine 2x. Y is equal to sine 2x. So in my head, I'm thinking of y is equal to this here. I have to make it a single term. I'm thinking of y is equal to sine 1, sine u. Clear? In my head. If I differentiate sine u is there in your book, I think it gives you cos u. Like this. So which means this dy over dx is equal to cos what is u 2x. But multiply by the differential here of what is the differential of 2x? 2. So that gives me 2 cos 2x. Making sense? Now, what if now we have something like this? So y is equal to e to the power of 4x cos 4x. So here we have to do both product rule and chain rule. So dy over dx is equal to, if I choose to differentiate this, it's 4 e to the power of 4x. We don't differentiate this, so cos 4x. Plus, this time we don't differentiate this, so e to the power of 4x. But now we differentiate this. But in your head, you should think of cos u. What is differentiation of cos u? Check in your booklet, is minus sine u. So it's multiplied by negative sine, what is u? 4x. But multiply now by the u, differential of u, which is 4. Differential of 4x is 4 here. So we get 4 e to the power of 4x cos 4x. We have got a negative there, so minus 4 e to the power of 4x sine 4x. If you want, you can factor out 4 e to the power of x just to simplify things. Cos 4x minus sine. Clear?
Yes. Why don't you differentiate the cos?
So now,
Oh, I was saying
yes,
the
yes.
cos 4x minus sin 4x in the brackets at the end, why don't they like differentiate the cos 4x to say it's minus sin 4x so that they cancel each other out? They
No.
knew that.
This year, remember, we differentiated this year. We differentiated this, we got this. Then we don't differentiate this like your product. Plus, now we don't differentiate this. Then what we are differentiating is this here. So I said, just think of this as cos u or cos x. Differentiation of cos x is minus sin u. And what is u? U is this, like this. Then we multiply by 4. When we multiply by 4 here, what we should never do, we don't multiply this by that. This number always comes before the sign. How do you get that?
Mm.
Yeah. So that's why I took the other side like this. So it's minus here times that times that. So that's minus 4e to the power 4x. Clear? So
Yes.
what you should never do if I have cos 2x multiplied by 2, you should never multiply this. The number comes first like this. Now, what you're also required to know is if I have y, I'll start from this. We want to differentiate y is equal to sine squared. These ones are now the trick one. Sine squared x. Differentiation of sine squared x. How do you get that? Sine squared x is the same as y is equal to sine x squared x. Clear?
Mm.
So your u is sine x. If I can put it that way. Can do chain rule again. Your u is sine x. So this is the same as you're saying y is equal to u squared. Y is equal to u squared simply gives you 2u. So it means dy over dx is equal to 2. What is u? U is sine x. But multiply by the differential of what inside the bracket. What is the differential of sine x? Is cos what? Cos x.
Cos.
So I get 2 sine x cos x. Is that clear?
Mm.
So if I have y is equal to cos to the power of 5x. So dy over dx using chain rule, it means our u is cos x. So if it's cos x, this year we're just thinking of u to the power 5. If we differentiate that in our head, it gives us 5u to the power of 4, where the u is the cos x. So that gives us dy over dx being equal to 5 cos, now we reduce the power here, 4x multiplied by, what is the differential of cos x? There in the booklet is negative 1.
Negative sign.
So that becomes minus 5 cos to the power of 4x sin x. Making sense?
Mm.
Now, this takes us where I wanted, which is parametric. Differentiation of parametrics. if I'm given that the equation of the line has got an equation y is equal to 2x plus t, and that, sorry, this one here is equal to t squared plus 5. Like, that's an example. You can write that down. Then you are asked to find what is dy over dx. Yeah, that's what we call parametrics. So to do this here, dy over dx, because y is on top, is equal to dy over dt multiplied by dt over dx. So that is, that's in general like this. So what we do is we go back to this here and we find dx over dt. Dx over dt, differentiate that, you get what? You get 2. It gives you 0 clear with respect to t. Then dy over dt is equal to, look at this here, isn't that 2t? Then this is 0 here, clear? Then dy over dx is equal, remember we said dy over dt, which is 2t, multiplied by the inverse of this here, because this is dx over t. So the inverse of this is 1 over 2. So eventually you simply get t. Yeah. Making sense?
No.
Where did you get lost?
Okay, first you said dx over dx.
Dx over dt. So dx over dt, that doesn't make sense. We are differentiating this here with respect to x. It's dx over dt. So we got to the here display.
I was
Then
confused.
there we got dy over dt, which is 2t. Then we use this method here. Dy over dx is dy over dt multiplied by dt over dx. So it's 2t multiplied by the inverse of this. Okay? That cancels, that cancels. That's what we got it. Making sense?
Okay.
Now, on the same part here, they can ask you to write to write the equation of this in terms of y and x only. Now, if you observe here, because we now know the gradient, that's the general gradient. Now, if we observe this parametric here, we can make t, this with the formula here. 2t is equal to x minus 1. Therefore, t is equal to x minus 1 divided by 2. Then I substitute into this because I want it to be only in terms of y and x. So y is equal to, what is t squared? Is x minus 1 over 2, sorry, all squared minus what? Sorry, plus 5. Clear? Which means that's x minus 1 squared. 2 squared is what? Is 4 plus 5. Y. That's our equation, represented by that parameter. Am I making sense? Just hold on. Get the worksheet. Parametric. Just do 1 or 2. Okay, parametrics. We're going to be intimidated by this. So now we have something like this in the diagram. Find what? dy over dx in terms of theta. You see that? We have x is equal to that and the y is equal to that. Follow? So dy over dx is equal to, here we have to find dy over d theta multiplied by d theta over dx. That's the general. Clear? Let's do that together. Let's find dx over d theta. What is dx over d theta here? Integration by parts, this is 0 here. And this is simply what's differentiation of sine? This is a constant. Differentiation of sine theta is in that cos theta. Let's cos theta. Clear? We're done with the first part. Now the difficult part, dy over d theta is equal to this here. What is the differentiation of cos theta in your booklet? 2 multiplied by negative what? Negative sine theta. Plus, now chain rule, remember? We are simply thinking of this as sine theta or sine u if you want it that way. So differentiation of sine u is cos u. So this is cos u, which is 2 theta, multiplied by this here. Differentiation of this 2 theta here is 2. So you end up getting minus 2 sine theta plus 2 cos 2 clear? Then apply this here. We said cos theta what dy over which is this, so negative 2 sine theta plus 2 cos 2 theta multiplied by the inverse of this, which is 1 over 2 cos theta. Every? So now let's factor out the 2. So 2 brackets negative sine theta plus cos 2 theta on the top divided by 2 cos theta. That cancels, that cancels. Clear? Then we have minus sine theta plus cos 2 theta divided by cos theta. Does that make sense?
Yes, sir.
That's what we do. So, verify that dy over d theta is equal to 0 when what? When that is equal to theta. Clear? So we now have the bracket. So we're saying minus sine theta plus cos 2 theta divided by cos theta is equal to 0. Cross multiply, this becomes 0, so it becomes minus sine theta plus cos 2 theta is equal to 0. Clear? So move that the other side, it becomes cos 2 theta is equal to sine theta. Like that. Making sense? Now, what is cos 2 theta? We have that we want to, in terms of sine theta. What is cos 2 theta? Check in your booklet. I think there is something which says cos. Check under identities. Cos 2 theta would be equal to 1 minus 2 sine squared theta. Like this. You have that identity. That's the one that we want to use. It's there in your booklet. So that everything is in terms of sine theta. So we replace this here with 1 minus 2 sine squared being equal to sine. Are you together? Clear?
I don't see it.
Is there under the trigonometry identities? We have that cos 2 theta 1 minus 2 sine squared theta.
Okay, yeah.
Then I move everything to the right side so that this is a positive. It becomes 2 sine. I want to form a quadratic theta plus sine theta minus 1 is equal to 7. Clear? Then, if I want, I can say let x be equal to sine theta. So that this equation becomes 2x squared plus x minus 1 is equal to 0. Then, let's see if we can factor it out. We have perfect vectors. So we've got an x here, we've got negative 1, positive. So we can have a plus 1 here and a minus 1, correct? Because this gives you minus x, this gives you 2x, which gives you x here. Clear? Then x is equal to half or minus what? Minus 1. Are we together? But what is x? X is theta. So we are saying sine theta is equal to minus 1 or half. Then theta is equal to arcsine of half. This is what we want to verify here. Arcsine of half is 30 degrees. 30 degrees is pi over 3. But your calculator will give you straight away in radians if you do this. Pi over 6. Exactly. Okay, we'll give you a break. We pick it tomorrow from this. We'll see you tomorrow. I'll send the record.